All right, so today we're going to extend upon our knowledge of solving two-step equations to word problems. So you're going to need your own sheet of paper for this. So grab a sheet of blank paper, and instead of folding it in half, you're going to fold it in thirds. So I want your paper, if this is my paper over here, here's my title. My title will be two-step equation word problems, and then you're going to split it across like this. The first column is for information we know. The second column is for information we're going to find. And the third is for our work and our equation. Pause the video, make sure your paper's set up, and then we'll get ready to go. So here's our first problem. Caden figures the problem will cost him $160. He has saved $46 and can earn $6 an hour at his job. How many hours will he have to work in order to be able to go to the prom? Now, I know some of you can figure this out just by doing some subtraction and division, which is totally fine. But remember, we want to practice and make a foundation. So when this becomes a little bit more advanced, we can figure it out easily. So here's my no box, my find box, and my work box. So things that we know, the prom will cost him $160. So total cost is $160. What else do we know? We know he has saved $46 already. What else do we know? He earns $6 per hour. Okay, that's a good start. How many hours will he have to work in order to be able to go to the prom? Well, that's what it's asking us to find. Number of hours he needs to work. And the piece of the information that we don't know, that's going to be our variable. Since we're talking about hours, let's choose H. Let's come back to our no box and define H. H equals the number of hours he needs to work. Once we have this information, we're ready to write our equation. Remember, your total goes on one side of the equal sign, so our total needed is $160. Now, he can have more, so this could potentially be an inequality, but for now, we're just going to make sure he has exactly $160. And we know that he already has $46. So that's going to be our constant. What we don't know is how many hours he's working, but we do know that he gets $6 per hour. So that H is going to be multiplied by the 6 because the 6 is talking about money per hour and the H is number of hours. Once we're here, we're ready to solve our equation. We'll subtract the 46 from both sides. Right? We'll do some borrowing to subtract. Our additive inverses cancel out. 6H comes down. Back to solving a one-step equation. We'll divide both sides by 6. And we'll do a little bit of division here on the side. Divide 114 by 6 on your own. And you get 19 equals H. We always want to go back and see, did we answer the question? Well, the question was asking us to solve for H. Did we solve for H? Yes. And finally, we'll always write our answer in a question. Sorry, in a sentence. Caden will need to work 19 hours in order to be able to go to prom. Use the words in the question to form your answer. All right, let's try again. So skip a line. So if you're doing it on your paper, so we just finished this problem, skip a line, and we'll try the next problem together. The goal here is to make sure you can get to this point with the equation accurately. We've already practiced the solving part. Here we go. Jackson is in a phone booth with $1.35 in change. A call home costs 60 cents for the first 5 minutes and 15 cents for each additional minute. How long can he talk? Now, I know that this might be a little bit out of date because we really don't have phone booths anymore. But it used to be the case where you have to go into a little box, put in money into a phone, and then you could use that to call. Now with cell phones, that's kind of extinct, but we're going to go with it anyway. So, what do we know? Jackson has $1.35 and change. So total is $1.35. A call home costs 60 cents for the first 5 minutes. So we're going to write that down. 5 minutes is 60 cents. And then 15 cents for each additional minute. So each additional minute is 15 cents. How long can he talk? So that's our middle box. How long can he talk? Well, do we know how long he can talk right now? We don't, so we need to pick a variable. Let's call that maybe M for minutes, and we're going to define our variable over here. What does M represent? This is a tricky one because we have additional minutes, and then we have the 5 minutes. So is M the total minutes or how many additional minutes he can talk? It's the additional minutes, exactly. Okay, so here we go. Our total goes on one side of the equal sign. We know our constant is for the first 5 minutes. We already know that's a base cost. It is not changing. But then we have additional minutes at 15 cents per minute. So there's your equation set up. Now your job is to go solve for M. Once you solve for M, remember that's your additional minutes, but it's asking how long can he talk? So in the pop-up box, make sure you're figuring out how long he can talk in total, and then write a sentence. Let's try a different variation. Skip a line. Here we go. A 120-foot long rope is cut into 3 pieces. The first piece of rope is twice as long as the second piece of rope. The third piece of rope is 3 times as long as the second piece of rope. What is the length of the longest piece of rope? There's a lot going on here. So let's start with our no box. What do we know? Well, we know the total length of the rope, right? The total length is 120 feet. And we know there's 3 pieces. Piece 1, piece 2, and piece 3. That's a good start. Now, if we reread this, we see it tells us something about the first piece of rope, and it tells us something about the third piece of rope. Which piece of rope does it not tell us anything about? The second piece. That's going to be your variable. So X is piece 2, the length of piece 2. And in this case, that means we've already defined our variable. Middle box, what is the length of the longest piece of rope? So our find box, what is the length of the longest piece of rope? Now, we have to really fill in piece 1 and piece 2 in our no box to figure that out. So here it says the first piece of rope is twice as long as the second piece of rope. Well, we know that the second piece is X, so twice means 2 times as long. So piece 1 would be 2X. And if I keep reading, it says the third piece of rope is, right? And is means equals if we remember. The third piece of rope is, so piece 3 equals 3 times as long as the second piece. 3 times as long, and the second piece is x, so we have 3x. So which piece is going to be the longest? Piece 1, piece 2, or piece 3? Piece 3 is, exactly, and that expression is 3x. So we have our total on one side of the equation, and we have our pieces, piece 1 plus piece 2 plus piece 3. Let's combine like terms. What's 2x, x, and 3x? 6x. Good job. Divide by 6 on both sides, and we get 20. Is that my answer? Well, 20 is the length of which piece of rope? That's the second piece. But we said the question was asking us for the third piece of rope because it's the longest. So we have to substitute 20 in here, which will make the longest piece of rope 60 feet. Make sure you're double checking that you've answered the question. So let's write a sentence. The longest piece of rope is 60 feet long. Excellent. All right. This one is for you to try on your own. So set it up with your know, find, and work boxes and see if you can come up with the equation and the solution. Pause the video so you have the problem on your screen to work out. Great job. See you next time.